Now let us start with what are the different algebraic operations which we can perform with matrices. First, most important is finding out the equality of two matrices. Now, when can we say whether two matrices are equal? First of all, their order must be same, and once their order is same, we must say that each and every corresponding element, where let's say I is equals to I for the other matrix and j is equals to j for the other matrix, those equal elements must also be equal. So for example, here you can see that 1 is equal to 1. First of all, you check the order. This is a 2 cross 2 matrix, this is also a 2 cross 2 matrix, and then you check all the corresponding elements. 1 is equal to 1, 2 is equal to 2, 3 is equal to 3, 4 is equal to 4. That means this is an equal matrix. Now what might happen sometimes is, for a matrix, you might have the order is same, however the elements are not same, corresponding elements are not same. Then what do we call such type of matrix? Such matrices are known as our equivalent matrix. So you must remember this as well. You must understand the difference. Equivalent matrix is where the order is same but the elements aren't. Equal matrix are the ones where order is same as well as the elements are also same, and also the elements which are corresponding. For example, if I have my first matrix where I am representing each element by aij, and in my second matrix I am representing each element by bij, then these two must be equal to each other. That means a11 should be equal to b11, a21 should be equal to b21. So this is how we are supposed to write it down. Now talking about addition of matrices, again the order must be same for all types of algebra except for multiplication. We will look at it how we are going to perform that as well. The order must be same. So for addition of matrices also, the one first most major thing is that order should be same, and then we can simply add the corresponding elements to get our resultant element. So for example, here let's say I'm adding a and b to get a resultant matrix which is C, whose elements I correspond as Cij. So I can say that Cij is equals to aij plus bij. Here in the example also you can see A is 1 2 3 4, B is 5 6 7 8. So my C matrix would become 1 plus 5, 1 and 5 are added, 2 and 6 are added, 3 and 7 are added, and 4 and 8 are added. So basically corresponding elements are added. So you can see 4 and 8 add up to 12, 3 and 7 add up to 10, 2 and 6 add up to 8, and 1 and 5 add up to 6. So this is how addition is performed. Now for subtraction, again the same concepts are used. The order first of all must be same, and once the order is same, we can say that Cij is equals to aij minus bij. We can subtract the corresponding elements from each other. 3 would be subtracted from 7, so we would have minus 4 here. 4 would be subtracted from 6, so we would have minus 2 here. Now talking about multiplication of a matrix by a constant. Now let's say if I have a matrix, A matrix, which is A, B, C, D, E, F, G, H, I. Let's say this is my 3 cross 3 matrix, and I multiply this with a scalar constant k. Then what would be my resultant matrix? It would be Ka times Kb times Kc, Kd, Ke, Kf, Kg, Kh, and Ki. So you must remember this thing, that if I multiply a constant to a matrix, each and every element of that matrix will be multiplied with that constant. So here you can see, let's say B is my resultant matrix, so Bij becomes K into Aij. Here in the example also you can see I've taken my scalar to be 3 and I'm multiplying it to my matrix A. So basically I'm trying to find out 3A. So what would it become? 3 into 2, 6, 3 into 4, 12, 3 into 6, 18, and 3 into 8, 24. So this is how scalars are multiplied to any of the matrices. Now comes the most important part. Multiplication of any two matrices. Let's say you have been given two matrices. Now here the order should not be same. It can be, the orders can be same. However, The thing is, when they are not same, still we can perform multiplication here. The only criteria here is that, let's say if I'm multiplying A, which is m cross n order of matrix, and I'm multiplying it with B, which is a n cross O, let's say, matrix. So what am I going to get the resultant? Resultant is going to be C. And what is the order of C going to be? It is going to be m cross O. So from here you must see that the row of B and the column of n A should be same. So here, from here you can eliminate these two, and from both these matrices, and you would get m into O as your resultant matrix. Now let's say if I would have A m cross m n, and B would be, let's say, my n cross m. So I would get my resultant to be, let's say it is C, it would become m cross m, because n here would be removed. Let's say if I have A times of n cross n and B times of n cross n, both are my square matrices, then what would I get my resultant to be? It would also be a square matrix of n cross n. So you must remember this thing. It is not necessary that the order must be same. Yes, the order can be same. However, there is one more criteria, that if I have the number of columns of the first matrix equal to number of rows in the second matrix, then also I can multiply both these matrices. However, the vice versa does not happen. Let's say if I have B, if I take the same matrix B n cross O, this one, and I multiply it, I have B n cross O and I multiply it with A. Now I'm doing the reverse operation with the same order matrices. Now I cannot multiply these two because the number of columns here is not equal to number of rows. So this cannot be performed. Thus, this is not defined. The multiplication cannot be performed. So you must remember this thing. And once, let's say, our orders are same, how do we perform the calculation? It is performed in this manner. Summation Cij is equals to summation aik dot b kj. Here k goes from 1 till n. We'll show you an example to understand, help you understand better. Here you can see that my A matrix has order 2 cross 3 and B matrix has order 3 cross 2. Now I am trying to find out A into B. So what would I say? That A is my 2 cross 3 matrix, B is my 3 cross 2 matrix. So here I can see that this is same, so this gets removed. So my resultant would be C, whose order would be 2 cross 2. So you must understand this. Now how am I going to find out each and every element of C? It is simply going to be multiplying the corresponding row with the corresponding column. So like to find out this first element, C11, what do? Is I multiply this row and this column. So you can see that 1 into 7 plus 2 into 9 plus 3 into 11. So you can see that 1 gets multiplied with 7, 2 gets multiplied with 9, 3 gets multiplied with 11, and all these 3 are added to get our first element. So this becomes 58. Now for the second element, again, now we perform the same operation but in a different way. Now we have the same row, since we are going to find it out in the row. Now we take the other column, 8 to 10. Now we again correspondingly multiply and then add. We would have 3 into 12 plus 2 into 10 plus 1 into 8, like this, and we would have 64 as our answer. And then for the more other elements, we would have 4 into 7, this row and this column, and then at the end we would have this row and then this column. So this is how our multiplication is basically conducted. Now one more important thing that you must remember here is that, let me do it here only. Let's say if I have again A m cross n is getting multiplied by B n cross O. So of course my solution would be C m cross O. Now here my m, this order is known as my pre-multiplier, and this O here, this is known as my post-multiplier. So you must remember this terms. Sometimes in questions they might not directly give you the order, instead they might give you the pre-multiplier is this, the post-multiplier is this. So you must understand that the resultant of two matrix would be of order which is pre-multiplier times post multiplier. So you must remember that as well. Now talking about a few properties of these algebras that we have studied. First of all, for addition, it is a commutative property. A plus b is equals to b plus a. Associative remains the same. Additive inverse, a plus minus a gives us 0. Now for scalar, k times a plus b gives us ka plus kb. Now if I have a matrix A which is of order, let's say n cross n square matrix, and I multiply it by a constant k, then I hope you all remember each and every element gets multiplied with that constant k. Over scalar addition, k plus m times a matrix, this would give us k plus ma. Again, the same things. Now for matrix multiplication, you must understand that AB would not be equal to BA. It can be, of course, but there would be certain conditions for it, but always this is not the case. So you must remember this. AB is not equal to BA. Even if their orders are same, let's say if I have both as square matrices, n cross n and n cross n. So of course my resultant would also be C, which is n cross n, but still AB would not be equal to BA because the elements would come out to be different. So you must remember this property. Apart from that, the associative and distributive property remains same. And now comes the use of our identity matrix. Any matrix, if it is multiplied by my identity matrix, I would get A as my answer. So my identity matrix, when multiplied, of course, when added it would create a difference, when subtracted it would create a difference. However, when multiplied, it wouldn't create a difference in my other matrix. However, now let's say if I have a constant k times of I matrix, then I would have k at my diagonal elements. My identity matrix would change. However, both here are my matrices. So when two matrices are multiplied and one of them is an identity matrix, I would get my answer to be the other matrix A. One more thing you must remember, this is also equal to now I into A, because of course A into I is equal to A, so I into A would also be equal to A. However, this does not work if this wasn't my identity matrix, as you can see here. Now let's say if I have I to the power n, this would always be I. So you must remember this thing as well about identity matrix. If I have an identity matrix and I'm constantly multiplying it with each other, I would still get an identity matrix. Multiplicative 0, if A is multiplied by a 0 matrix, we get 0 null matrix only as our answer.